In the diagram below, line KF is the perpendicular bisector of segment GH. We're completing the congruent statement. Angle KGF is congruent to what angle? So if we mark the information that we're given, we know that a perpendicular bisector does the two things its name suggests. It creates a right angle relationship between KF and GH, and since it's bisecting segment GH, that means that F is the midpoint and GF and FH are congruent segments. We also know that these two triangles share side KF, so it's congruent to itself by the reflexive property. So we now know that these two smaller triangles are congruent to each other using the shortcut side, angle, side. We have also learned that once we know two triangles are congruent, we know that the corresponding parts of those congruent triangles are congruent. So that's 6 relationships that we now know. Not only are these two sides congruent and this side congruent to itself, but this side is congruent to this side. We can also mark the other congruent angles that we know. Not only are the right angles are congruent, but the angle between 1 and 3 arcs is congruent to the one between 1 and 3 arcs over here. The one between 2 and 3 arcs is congruent to the one between 2 and 3 arcs of the other triangle. So now we can complete our congruent statement. Angle KGF is the KGF, the one with the 1 arc. So we're wanting to choose this angle right here that's congruent to it. So FKJ is this angle with 2 arcs, so that's not the correct answer. You cannot name an angle with 2 vertices. We've talked about how you can name it with 1, like we could call that angle H since there's not another angle H, but you would never name an angle with 2 vertices. KHF is the angle that we're looking for, that angle right there. Remember, the middle letter is the vertex of the angle, so choice C.